Hello, my friends. It's the NOLA Mathman coming again for another fun math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to solve problems related to trigonometric ratios. The concept we're looking at is radical functions in geometry. The skill we're looking at is trigonometric ratios. So with no further ado, let's get started with our video. So in this first problem, we want to find the value of the three trigonometric ratios for angle A, which is at the top right of the video. We must label our sides. The shorter side is going to be A, the middle side is B, and we set C, the hypotenuse, equal to C. So we want to use the Pythagorean theorem like we did in the last section to find one of the three sides that's not given. So that's A in this case. So we substitute B and C into the equation A squared plus B squared equals C squared, and we will solve for A. We do that. 77 squared is 5,929. 85 squared is 7,225. At this point, to solve for A, we must subtract 5,929 from both sides because it's positive, so the inverse is subtract. A squared is equal to 7,225 minus 5,929. That will give us A squared is 1,296. To solve for A, we take the square root of both sides. A is equal to 36. So now we write that on our figure. Once we have all three sides, now we can solve for the three trigonometric ratios. So the first trigonometric ratio is cosine. Now the formula for cosine is adjacent over hypotenuse. So again, in order to do that, we must find the relationship of the three sides in relation to A. The B side is the opposite because as you can see it's the opposite side from angle A. C is always a hypotenuse. And A, which is close to angle A, we call that adjacent because it's next to A. So we always want to label our three sides either adjacent, hypotenuse, or opposite before we start calculating the trigonometric ratios, because that's very important. So since cosine A is adjacent over hypotenuse, we substitute the sides adjacent and hypotenuse, and cosine A is 36 over 85. Sine A, you write the formula. The formula for sine A is opposite over hypotenuse. We substitute 77 for opposite and 85 for hypotenuse, and so our ratio for sine A will be 77 over 85. As you can see, the NOLA Mathman circles answers because we want to do that, so we'll be clear with our answers. We have one more major trigonometric ratio called tangent. Tangent A is opposite over adjacent. Since the opposite is 77, we substitute that in. Adjacent is 36, and so our ratio for tangent A will be 77 over 36. And so we have solved the values of the three trigonometric ratios of angle A in this particular problem we have. So we're done. So we get that all out the way. And again, it takes a little while to get used to, so we're going to do a few examples. So now we're going to bring up another right triangle, expand it so everybody can see it. And so, again, we want to find the values of the three trigonometric ratios for angle A. Now, just like the first problem, we only have two of the three sides. So our first step is to use the Pythagorean theorem to solve the missing side. In this case, the missing side is the longest side, which is our hypotenuse, which we always label C. So we will substitute for A and B in. As you can see, the NOLA Mathman has already labeled the sides A and B. We substitute it into the equation A squared plus B squared equals C squared, and we solve for C. So 8 squared is 64. 15 squared is going to equal 225. We add those together, and that must equal c squared. That would be 289. To get c, we do the inverse of both sides, which means we take the square root, and side c will equal 17. That will be the length. So now that we do that, we can label our triangle, and now we're in a position to find the 3 trigonometric ratios for this angle A. That's what we're going to do. So it doesn't matter order in terms of cosine, sine, and tangent. You can put cosine first, sine, it doesn't matter. And sometimes the NOLA Mathman may do different ones just to show you it doesn't matter. So before we do the trigonometric ratios, we have to determine which sides are opposite, adjacent, and hypotenuse, and that's what we do. So we got angle A, 17 is the hypotenuse, this is the longest side, 15 is next to A, the B term will be the B side, or B will be the adjacent side, and the A will be the opposite side, since it's opposite, side A is opposite of angle A. So again, cosine is equal to adjacent over hypotenuse. We substitute adjacent and hypotenuse, and the cosine of A is 15 over 17. Sine A, the rule is opposite over hypotenuse. We substitute 8 for opposite and 17 for hypotenuse, and so the ratio for sine A is 8 over 17. Again, we want to circle our final answers. And then the third ratio is tangent A is equal to opposite over adjacent. We substitute 8 for opposite and 15 for adjacent, and so our tangent A ratio will be 8 over 15, as we'll see there. So we're done with our 3 trigonometric ratios for this particular problem. So again, same process as the first problem. Again, the neat thing about math, you do the same process over and over. So now we got a different type of problem. We're going to use a calculator to find the values of trigonometric ratios. So you're going to learn how to use your calculator to determine trigonometric ratios and learn how to round them to the nearest 10,000. How many places to write a decimal is 10,000th place? You're correct. It's the 4th decimal place to the right of the decimal. So that's what we're going to do, 4 decimal places. So our first problem is sine of 18 degrees. You simply get your calculator, you put 18, you press sine, and you will get a value. And so this value rounded to the nearest 10,000 will be 0.3090. So this is a very simple problem. There's not a lot of steps. You just plug it into the calculator and get your value. So now we have cosine of 68 degrees. We substitute that into the calculator, and it will push out a value. We round it to our nearest 10,000th place, 4 decimal places. And so that value will be 0.3746. And then the last problem we're going to do is tangent of 27 degrees. And again, we plug that into the calculator. You want to round the nearest 4th place. And how do you do that? You look at the 5th, and if it's higher than 5 or more, you round up, and if not, it stays the same. So tangent 27 is equal to, it was there on the board. I guess they got a little ahead of Mr. Brown there, the NOLA Mathman. So, but it was there on the screen. So these go quickly. You can just plug them into your calculator and get the answer very quickly. So now we'll go to another group of 3. We have cosine of 60 degrees, tangent of 75 degrees, sine of 9 degrees. So again, get your calculators out so we can do these. They go very quickly, as evidenced by this last problem we just did. So you get your calculator out. Cosine of 60 degrees, you plug that in, and you will get a value of 0.5. So there's nothing to round there. If you wanted to round it to the nearest 10,000, you just put 0.5000, as the NOLA Math is just indicated. Because zeros don't change the value. So now we're going to do tangent 75 degrees. You push tangent on your calculator and you will get 3.7321. So again, the value of tangent is 75 degrees, 3.7321. Then the last problem we have here, sine of 9 degrees. I'm going to plug it into the calculator and we'll produce an answer, and we round it to the nearest 10,000, don't forget that, and the answer will be 0.1564. And so that's the value for sine of 9 degrees. And so there we go, we're done with those. And so what kind of problem are we going to do next? We've done two types of problems that utilize the trigonometric ratios. What is the NOLA Mathman going to do next? So now we're going to solve each right triangle and we're going to round each side length to the nearest 10th. So again, this is a very good application of trig. You have to use, you're not given all the sides, you're given one side and one angle, and then you have to find the other sides. So we label the side given 13 to B. We're looking for A, which is opposite of 17 degrees. We want to label that. The B term would be the adjacent side. And the C term, since it's the longest side, is the hypotenuse. So in order to find our sides, we start by using the tangent of B. Since we're given B, tangent is opposite over adjacent. We're given adjacent, so we substitute 17 degrees for the beta of B, and we substitute 13 for adjacent. And now by solving for A, we can now solve for A because basically we only have one unknown. To get A, we will multiply both sides by 13 because that's the inverse of division. And so A is equal to 13 times tangent of 17 degrees. So now you get your calculator and you're going to plug in tangent of 17 degrees. You're going to multiply by 13 and you're going to get a value that you round to the nearest 10th. In this case, A is going to equal to 4.0. So that's going to be the length of A, side A. Write that on your triangle. So now we have one more side to calculate, and then we'll be done with this problem. We have the hypotenuse we have to calculate. So how do you do that? Well, we can use a trig function that involves the adjacent, because we have that given, with the hypotenuse. So what trig function do you think has adjacent and hypotenuse? I'm testing you. If you've done it enough times, you're correct. If you said it, it is a cosine. So we're going to use the cosine function to solve for the hypotenuse, which should pop here on the video in a second. So we're going to use cosine of B is equal to cosine of B equals adjacent over hypotenuse. So that's what should pop up on the screen here in a second. So again, we go back to labeling the sides of the right triangle, opposite, adjacent, or hypotenuse. So as I said, cosine has both adjacent and hypotenuse. So since we're given adjacent side, we substitute 13 for adjacent. We put 17 degrees for B. And we now will solve for side C. Now, in order to get C is in the denominator, we know that we can divide 13 by cosine of 17 degrees to get C. And that's a little trick if you know division. And so you get your calculator out, you plug it in, and that value will be 13.6 rounded to the nearest 10th. And so now we have all three sides, A, B, and C. A is 4.0, B is 13, and C is 13.6. And again, the hypotenuse is greater than the other two, so that's a good way of checking if you got good values whenever the C term has to be bigger than the other two sides. And that lets me know I'm on the right track. So that was the case in this problem. So the answer should be pretty good. So now we're going to move that out the way. So we did a problem where we solved the sides of a right triangle. How do you use trigonometric ratios to solve a missing angle? Maybe that's what we're going to do. Oh, look what pops up. It says find the measure of angle J for each right triangle to the nearest degree. So in this problem, we're looking for the missing angle given sides. So that's what we're going to do in this particular problem, number 14. Now, in relation to J, what do you think we're going to do first? Well, I think we should label the three sides of the right triangle in relation to J. What side is going to be opposite? What side is going to be adjacent? What side is going to be hypotenuse? And so as you can see here, the adjacent side is going to equal 11. Since 19 is the longest side opposite the right angle, we know that that is the hypotenuse. So in order to solve for J, we want to use a trig function that has adjacent hypotenuse. That's cosine. So cosine J is adjacent over hypotenuse. We substitute our values in, 11 over 19. J is going to be the inverse cosine of the ratio of 11 over 19. You get your calculator, you press the inverse cosine, and it will produce an angle, which we round to the nearest whole degree. And so in this case, J is going to equal 55 degrees. So again, we have done a problem where we have to find the missing sides with a trigonometric ratio. Now we've done an example where we're finding missing angles using trigonometric ratios. So we've done a variety of different problems. Again, we're done with this particular math adventure. So until we meet again to do another exciting adventure, this is Mr. Brown, or AKA the NOLA Mathman, signing off. Have a blessed and prosperous day. Bye-bye.